In this video, we're going to be talking about variations on the equations of tangents and normals problem. So I'll just have a little read of this one that I've got on the right hand side of the screen. We've got a point P and it's somewhere on the curve x squared minus 8x plus 20. The equation of the tangent at this point is of the form y equals 4x plus c. And the objective here is to work out the coordinates of that point and find c, which in this case is the intercept of the line. Now, what makes this problem slightly different is rather than being given coordinates that we can plug in to dy dx, we're just given a tangent y equals 4x plus c. And the only real thing that we can infer from this is the gradient of the tangent is 4, and that's about it. You can think about this problem geometrically. Here's a straight line, one I made earlier, and here's a point P. Now this line's got gradient 4, and really what we're doing is we're saying somewhere on this curve I could place this line and it would behave as a tangent, and I think it's roughly here. Yeah, that looks good, doesn't it? So we need to work out the coordinates of this point. Now the place I'm going to start, I'm going to take this equation of a straight line and I'm going to differentiate it, and in this case I'm going to get 2x minus 8. Now I don't know an x value to plug in, but what I do know is the gradient of the tangent is 4. So what I can actually do is I can plug in 4, but I'm going to plug it in for dy dx because that represents my gradient. So I'm going to replace dy dx with 4, and then my problem becomes I'm asking where on the curve is the gradient 4, and I will get an x value out, so I'll get part of a coordinate out. So I'm going to chuck a 4 over here, and I'm going to rearrange this formula very slightly. 4 plus 8 is 2x, so that's 12. And from here, I'm going to get x is 6. So what that tells me is the x value for P is 6. So now that I've done that part, the problem starts to unlock. I've got the x value for P. If I want the whole coordinate, I need to plug that x value in to the original equation. So let's do that. I think I might need to scroll it down a little bit here. So let's do that as well. So the curve equation is y equals x squared take away 8x plus 20. I want to know the y value when x is 6. So I'm going to replace all of the x's with 6's. And in this case, I'm going to have 36, take away 48 plus 20, and I believe that's going to work out as plus 8 in this case. Therefore, I can include that in my coordinate. So the coordinates for P are x is 6, y is 8. So my straight line is y equals 4x plus c. And I know that the point 6, 8 is on that line, so I'm going to replace y with 8, x with 6, and I'm going to solve it. And if I work out this one, I'm going to get an intercept of minus 16. Cool. So then the entire equation of the tangent in this case is y equals plus 4x minus 16.